Hi everybody, this is Mrs. Ellsworth, and this video is our third video of the Physical Science Electricity unit, and in this one we're talking about resistance. Okay, and from how do we calculate different parts of the resistance in different types of circuits. So in this one right here, what kind of circuit is this one? And you'll notice that it is a series circuit, and so to find the resistance, the total resistance inside of a series circuit is really nice and simple. We just add them up. Okay, so we would go and add up, doesn't matter which resistor that you have in which order for R1 and R2. This would continue. If you had more resistors, it would keep continuing, and you just add them up. So then we will get 350 ohms for this circuit diagram right here. Now mind you, we just figured out resistance. We've got voltage here. I could ask you also to calculate the current using Ohm's law. So that's just a thought to think about there. Okay, now the formula for the parallel circuit, there's a parallel circuit. It is much more complex, and I wish it was as nice and simple as the other one was to calculate, but it is simply not. So in this one you have to use the reciprocals. Okay, to find the total of this, you're going to have to find the reciprocal of all of these fractions, the reciprocals of each resistor added together. So let's go and kind of take this apart a little bit. So we're going to have to find our R total, and then it's going to be 1 over one first resistor and 1 over the second resistor. It'll look like this. Okay, now this is fine when you think about it, but this is 1 over R total equals this value. So that's not what our answer is. We have to go and take the reciprocal of this. And there's a button on your calculator on both the yellow ones and the other ones, and you press this x to the -1 to find the reciprocal of it. On some calculators it's also 1 over x button, but this is the one that we press for ours. And so we'll go and we'll press that x to the -1, and so it's really finding the reciprocal of this 0.14 value, because our answer equals 1 over our total. So we have to go and find the reciprocal of it, and so we'll get 71.43 ohms. Now think about this compared to the series circuit. The series circuit had 350 ohms. So it had 350 ohms, so that meant that the series circuit, the resistors really slowed it down because they had so much resistance in that series circuit compared to the parallel circuit. So it makes the current go even slower in the series versus the parallel. Just some food for thought there, to think about, well, what's happening? How does it make that current change? And in this case right here, remember that voltage is really that pressure behind that battery to make it go through and connect and make its loops. So you can always do more with your resistance. When you know what your voltage is, you can also find the current. Now let's do one more thing. We're going to look at the power and also energy calculations that are used with current and voltage and resistance. Okay, so here's our formula for this one, but usually we are just solving for P. We're looking for power, so it's going to be I times V. If you're looking for current, it would be power divided by voltage, or potential difference. And if you're looking for the voltage, or potential difference, it would be power divided by current. Okay, so here's our problem. We've got an electric oven that is connected to a 240 volt line, and it uses 34 amps of current. What is the power used by this oven? So you would set it up P equals formula, and that'd be P equals I times V. So I have it all set up here, and we'd have 34 amps for our current, and we'd have 240 volts for our voltage or potential difference, and we'd just multiply them. And we would get 8,160 watts. Okay, notice that power is watts again. We still have the same unit for power, whether it is the power that your body is doing when it's going up the stairs, or whether it is the power that is happening with electricity. And you know that when there's a certain power, you can stick a light bulb in and it'll light up. Other times it may break it because there's too much power going through it. And so we have to pay attention to the watts of our appliances and how much wattage is going through the lines. Okay, there's also the energy formula. Okay, this one is energy equals power times time. And so when we calculate this one, it's it's neat. I mean, you could go and ask for power, but usually we're just looking for the energy. And that's going to be we got to change this to kilowatts times the hours. And it must be in those units, kilowatts and hours, because the energy unit is kilowatt hours. Let's look at this problem over here. A clothes dryer has got 5,400 watts. We're going to change that into 5.4 kilowatts. Okay. And it is ran for 2 hours. How many kilowatts are used? And this should actually, I'm sorry, there's a typo here. It should be kilowatt hours are used. So it's just a nice multiplication problem. Energy equals power times time. And it is going to be 5.4 kilowatts times the 2 hours, and you're going to get 10,800 kilowatt hours. If you even go look at the meter on your house, it reads in kilowatt hours because it's figuring out the rate at which the energy goes through your home, or that is used in your home, I should say. So I have one more question for you before we're going to close, and that is what type of circuitry is in your house? And you got to always think about that lab that we did where you unscrewed a light bulb and other things ran. That's a big, huge hint, because if certain things burn out in your house, it's a parallel circuit. Okay, now I want you to try and do one thing before we meet tomorrow, and I want you to look at this circuit. Okay, it's a parallel circuit. Okay, but it does have a resistor over here also. So we're going to have to figure out what is the resistance of these two parallel legs of this circuit. So I want you to do that. I want you to figure out what is the total resistance of a 6 ohm resistor and another 6 ohm resistor, and I want you to figure out what's the total resistance of just these two legs before you come to class tomorrow. It'll save you a lot of time because we're going to go through that part rapidly, and I will see you tomorrow.